Hi, this is Tommy, and this is my demo for the discovery exercise. Basically, what my device does is that it translates pixels to length. So let me show you kind of the image that we're trying to solve right now. In this case, we're trying to find out measured length based off the Canadian quarter. So this is my reference object that I'm using to calculate the pixel ratio, basically. Again, the diameter of a Canadian quarter is 23.8 millimeters, and so we can calculate the length and width of other objects based off this reference. So there's only 3 files that I want to talk about. Camera, GIF, and measure. What camera basically does is this. Camera basically opens a window called sensor, either waits for the escape key to close the window or spacebar to take a picture. So basically it opens the window, allows you to press spacebar and capture an image and save it to a file. So let me demonstrate this. So I've opened the sensor window. I see some images. Press spacebar to take image. You can't press exit until you press escape. And so that's basically what camera does. Measure is the edge detection logic. So again, the reason why it's in a notebook is so that I can show cell by cell to demonstrate what each cell does and what's happening in the logic. So basically, first cell is importing all these libraries and defining a bunch of functions that I need throughout the thing, such as midpoint, which basically calculates the midpoint of a line, show image, plotting the image, images the GIF, and saving the image. So the first thing we do in the edge detection is we load the image and we make it grayscale over here. And the reason why we need grayscale is that the RGB is unnecessary for the edge detection, which is based off the darkness of the outline and the edges, basically. The next part is the Gaussian blur. Basically, it blurs the image using a 9x9 kernel so that only the edges survive that blurring. So all unnecessary features, all that noise is blurred out, but the edges will survive because they're the darkest and they're the outline of the objects. And that allows the canny edge detection object to grab only the edges and remove all the kind of the unnecessary noise for the edge detection. And after grabbing the images, I did a dilation so that the edges will become more pronounced, so the imperfections will become more pronounced. But this ends up making the border thicker, so I did another erosion to make the border thinner, and so this is the final result with those edges imperfections dilated and showing the object itself, basically. And then made an array so basically each contour is an object that detects whether that's whether that's good or not. Let me show you the GIF again one more time. Again, there's a bounding box, and so basically what this last cell does is it creates that bounding box and that dimension calculation. This massive cell is for creating that box. It'll basically loop through every single contour it detects, and it'll create a box around that image. It will calculate the length and width of it based off of the pixels per metric. So this only runs the first time, which is the reference object we're talking about. Otherwise, it's null. Sorry. The first time it's null, so that it can capture the reference object. So you tell it what it bases off the reference. And other times it'll just calculate as per normal what that reference should be. Puts the text there and it appends it into one file, one GIF. So let me show you the full executable. The only difference is that I've added some bash arguments so that you can specify the width of the reference object and specify what the reference object is. So again, first grayscale and the Gaussian blur that remove the noise and make the edges more pronounced. The canny edge detection, which pulls out only the edges. This is a compilation of all the bounding boxes and all the measurements, which is kind of messy, which is why the GIF is more necessary to show each bounded box for 5 seconds so that you can understand what's happening in the background. While it's loading, or dying, I guess. Sorry, it takes a minute or two. I kind of want to show the end product before I end this demo. There it is. Okay. And so this is the final product. This is what the GIF.py does. It creates this window. I showed at the beginning. Again, it creates the bounding box. A dime is 18.05 millimeters based off the national standard, so it's actually pretty close. Yeah, and then nickel's actually 21.2, so it's very kind of close. Yeah, that's the end of the demo. Thank you.